So what we want to do now is move on to try and get some more equations that will allow us to remove some of the unknowns from the Friedmann equation and therefore actually solve it analytically. And we're going to do that by deriving two more equations. The first of these is called the fluid equation. And what the fluid equation notes is that the Friedmann equation is basically a statement of conservation of energy. Total energy is potential plus kinetic, it's equal to a constant. And similarly, the first law of thermodynamics is also a statement of conservation of energy. Now, I'm not sure if you have seen this material fully before, but it doesn't matter if you're not, you can take it as read if you have. And so this is what you write. And so this dq is what you call the heat flow into and out of a system. This is the change in the internal energy. This is the pressure, and this, of course, is a change in the volume. And there are various ways you can look at solving this. So, in our homogeneous universe, or homogeneous isotropic universe, dq equals 0. Formally, that means it's an adiabatic expansion. More generally, that condition of homogeneity and isotropy means that there can't be a heat flow because that will give you a preferred direction and will break the cosmological principle. So if I write this now as time derivatives, we're interested here in how things change with time. And therefore I can write that E dot plus P V dot equals 0. And so now let's look at each of these terms in turn. So V is just 4/3 pi r cubed is 4/3 pi r cubed x cubed in co-moving coordinates. So again, this is co-moving. And so I can write V dot is equal to 4/3 pi x cubed, because that bit doesn't change, times 3a squared a dot when I derive it. And then I can pull out, if I want, this bit again, the 4/3 pi r cubed x cubed. Sorry, a cubed, this is where I get it wrong. This is an a cubed x cubed. And that's equal to v times 3a dot over a. So yeah, apologies here, I wrote an r here originally. That is an a. V 3a dot over a. And then the internal energy well, the energy is just the volume, the function of time, times the energy density, which is also a function of T. So E dot is just V E dot plus V dot E. And then if I substitute in here, this V dot here, that's equal to V into E dot plus 3A dot over A E. Now if I combine everything above, so I write E dot plus P V dot, that's equal to V into E dot plus 3 A dot over A E plus 3 A dot over A P is equal to 0. And simplified further, that just becomes E dot plus 3 A dot over A E plus P equals 0. And that is the fluid equation. And then the final thing we want to come up with is the acceleration equation.